Tell me if this has ever happened to you. You ask one department for the definition of a product and you compare it against what another department says, and turns out to mean two totally different things. This is basically the problem that semantic layers set out to solve. Semantic layers work as a sort of Rosetta Stone for your data and aims to abstract the business of measurements and KPIs for users to easily understand. Consider the power of the context that semantic layers provide in the world of AI. Today, AI is the hot new thing, and semantic layers can provide the context that we spoke of in an earlier video that it so desperately requires. This is the power of semantic layers, and in this video, I want to talk to you about how to utilize them. After 20 years of data engineering and architecture experience, I've seen so many conflicting values without a lack of proper context. The so-called one version of the truth remains elusive without the power of semantic layers. A semantic layer is a business-friendly abstraction that standardizes business logic and metric definitions. Semantic layers mainly have three advantages. We already spoke of the ideal one version of the truth, and imagine the power of being able to consistently represent the data in a way that's understandable to everyone in a company. That's one of the key advantages of semantic layers. Self-service BI or empowering self-service. So semantic layers abstract away the complexity of writing, say, SQL code to non-technical users to be able to self-serve and get to values and measurements themselves. And then consolidated environments, enhanced governance. If we have a central place to deploy our metrics and definition, we buy a way in which to govern them. You might be wondering how the idea of semantic layers gel with the decentralized notion of newer architectural patterns such as data meshes and data products. The short answer is that these two are complementary and they can live alongside one another. Look out for a future video on the integration between these two patterns and one on data meshes as well. LLMs, or perhaps more correctly, foundational models, are essentially stateless text predictors. They use statistics to determine which words should come next. This is facilitated, or this is warranted to need for us to look into context engineering. Context engineering is the systematic discipline of assembling the relevant information that an LLM needs to complete its task and to provide context, as the word implies, to the information that we want to provide to the foundational model. Semantic layers have been around for a long time. I remember working in it when I first started my career in data, and initially they were meant to provide a single source of truth. I guess the elusive single source of truth still remains in business, but when semantic layers work, they can provide a powerful context in a sort of repurposing to foundational models. Imagine the agreed upon business measurements that you can give to a large language model to provide you with the refined and filtered information to accomplish its task successfully. That is semantic layers in this new world. A practical example would be if we look at, say, the top customer within our company, or the measurement of top customers, and we want to provide that LLM to write a SQL query for us. Imagine there's an agreed upon way in which to determine the top customers, and the semantic layer would act as an instruction manual to inform the foundational model to write the correct SQL query for us. That is the power of semantic layers in enriching the context for large language models. Think of retrieval augmented generation and how semantic layers can act as the ultimate external source in enriching your query sent to the large language model. That is the power of semantic layers. Semantic layers can architecturally be divided into three main types. First of all, we have our BI integrated semantic layers. Think of Looker in this case. Looker is initially was developed as a BI tool, and if we take the AI component out of it for a second, Looker envisaged to provide a semantic layer for business abstractions for end users. Benefits of this approach is a seamless user experience. The disadvantage naturally is that there's a lot of vendor locking in that you choose the BI tool and the BI tool has a semantic layer coupled with it. Another example of this type of semantic approach is Power BI. The second type of model is the platform native semantic layer. So think of technologies like Snowflake semantic views and Unity catalog in Databricks. These ones are sort of in between the BI integrated semantic layers and the universal or headless semantic layers. The platform semantic layers provide you with the ability to have centralized governance and metric consistency. The disadvantage of this approach is that you're locked into the platform. So previously, if you were locked into the vendor, in this case, you would be locked into the platform. And moving from Snowflake to Databricks, for example, would be more difficult in future. The third type of semantic layer is what we call the headless one or universal semantic layer. This approach provides you with a third-party semantic layer like Cube, for example, that has no dependency on any specific lock-in when compared to the other two. The benefit of this approach is naturally that you don't have lock-in. The disadvantage is that you introduce an additional component on your tech stack. Let's look at some of the main players in the semantic layer industry. First of all, we have DBT. DBT follows both SQL and YAML as the architecture type, and DBT Core is open source. Cube is headless BI, or if you will, API first. Cube is the one that's most open source and provides you with the ability to have a decoupled semantic layer. Looker semantic layer has also been around for a while and is probably more mature than a lot of the other players. Looker, of course, has a BI centric approach, or was designed initially around the BI centric approach, and therefore the price you have to pay for that is vendor locking. Databricks with Unity Catalog also have a centralized platform that provides you with a single pane of glass for your data governance. The last major one is Snowflake, who recently introduced semantic views to be able to compete with the likes of Looker and Cube. As you can see, the choice of semantic layer is not an easy one to make. Once you've made a choice, it's best not to add additional semantic layers to the equation and stick with one, because that would essentially defeat one of the main benefits of semantic layers, which is the idea of a single source of truth. Here's a decision chart to help you decide which semantic layer will work best. First of all, if you're heavily invested into the platform already, it makes sense to look for native technologies such as Looker, XML, or your data warehouse of choice, i.e. Databricks' Unity Catalog or Snowflake's semantic views. You might even want to consider that in the case of DBT and your level of investment in DBT. Look at the primary use cases in this diagram. If you have a diverse mix of applications and you value things like an API first approach, an additional technology such as Cube might be the best choice for you. Most importantly, you have to consider which works best for you and what your long-term requirements are. Remember that AI is upon us, and that the need for semantic layers that support AI will become even more prevalent in the future. Let's summarize what we've learned. Semantic layers will become a strategic asset for companies, considering that AI is moving from text-based answering to autonomous agents. A semantic layer and the correct context, by implication, will only become progressively important in your company's landscape. A semantic layer can be seen as a central nervous system that will provide the correct context and commands and unify your data landscape in future. Consider the value of your data in this context. Look out for a future video on the subject of the increasing importance of your data in the world of AI. That's it from me for this week. Please, if you like this video, don't forget to like and subscribe and tell your friends about it. Please get involved and tell me what you think. Thanks for watching.